introduce myself. My area of interest is breeding for a more sustainable food production with farm animals. I worked at the university for more than 30 years, but when I was young, I used to work with dairy cows on different family farms. That's long ago, and both the conditions for farmers and the animals have changed since then. The change of the animals is largely due to selection. It's a genetic change. The changed conditions for farmers are partly due to politics and competition on a global market, and partly due to climate change. All these changes are, of course, connected to each other. If you are a dairy or a beef farmer or advisor in milk and meat production, I assume you are concerned about climate change and other environmental impacts. You might also feel the pressure of an ongoing discussion about sustainable animal production. You work with ruminants, and the public discussion is often focused on climate change and methane emissions, right? With this lecture, I want to give a broad overview of strengths and weaknesses of milk and meat production. And the second aim of the lecture is to introduce life cycle assessment, a tool to assess sustainability of a production system. So this lecture has two learning outcomes: a broad view on animal production's environmental impact and knowledge about life cycle assessments. Sustainable production is often described as a production built on three pillars: environmental or ecological sustainability, social sustainability, and economic sustainability. In my lectures, I handle economy as part of the social sustainability. For example, a reasonable income for you is part of the social sustainability. When talking about sustainable agriculture, most people think of environmental sustainability. The climate impact of 1 kilo beef or the nitrogen leakage associated with 1 kilo milk is important, yes. But I believe social sustainability is equally important. This is also shown by UN sustainability goals. Most of them include both environmental and social goals. There are several ways of assessing the sustainability of the production of goods and services. One common approach is life cycle assessment, in which the impact caused by the production is related to the amount of products produced. A fundamental principle in life cycle assessment is to follow the impact of the product all the way from the production to consumption, and from consumption to handling of waste and recycling. Think of the screen where you see the Sustainable Development Goals now. How has this screen and how will this screen impact the environment and people during its lifetime? How much electricity was used to produce your screen? Was this electricity produced on coal or wind power? How much electricity was used to produce your screen? Was this electricity produced on coal or wind power? Was the laptop transported to you on a van run with fossil fuel? And what happens when your laptop is broken? Will the battery and other components be recycled? Is that done with toxic solutions? We must also think of the steps before your laptop laptop was built at the factory. These steps may include heavy metals from mines. What about the impact on the rivers in the country where cobalt or lithium mines are located? In a life cycle assessment, all inputs are traced from the production site back to their origin. If the product is food, the boundaries of the system is less evident. When the food is eaten, it's gone. And handling food waste and sludge from sewage treatment plants could be included in a life cycle assessment, but that is rare today. Now, imagine beef as the product we study here. Inputs to the farm could be electricity, fuel, fertilizers, and imported soy. If imported soy is used on the farm, we have to include the cultivation of this soy in Brazil or in China or wherever it comes from. Haven't you heard about soy from China? Soybean actually originated from China. It was domesticated many thousand years ago in China. And today, China produces soy used in organic production in Europe. The environmental footprint of soy production in Brazil and in China differs, and working conditions for the workers at these farms also differ between Brazil and China. So, when evaluating the sustainability of beef production, we should consider not only the production on the beef farm, but also the inputs such as feed, fuel, and fertilizers. It matters how these inputs were produced, and also it matters how the manure was handled. Therefore, the environmental impact of two farms can differ a lot, even if the farmers are neighbors and produce the same product, for example, raise dairy calves for slaughter. Consequently, the result of scientific studies on environmental impact of beef production can differ, which may be a bit confusing. We want to assess sustainability to be able to describe the impacts of production, to provide a base for well-informed decisions and wise choices. The assessment should help us doing a fair comparison between production systems, between different products, or between different farms. For the industry that wants to improve their production, a life cycle assessment can show if there is a favorable trend in the production system. For the consumers wanting to achieve a sustainable diet, results from a life cycle assessment can guide them, and these results can also guide politicians wanting to stimulate sustainable production and consumption. Now, wait a second. Are we talking about production or consumption here? Let me give an example. In Sweden, one of the national sustainability goals is to reduce eutrophication, to reduce nutrient leakage into the sea. Agriculture is responsible for a large part of this leakage. A quick fix would be to close all farms. But also Swedes have to eat, yes. But we can always import food. Less farms in Sweden, higher fulfillment of the eutrophication goal. But then we have course, just move the problem to another country. Thus, we should analyze the impact of both national food production and production of imported food, because we are responsible for the whole consumption of food of our population in our country, right? Likewise, we are responsible for the inputs imported from other countries, as soy, for example, and pesticides or the fertilizers. The life cycle assessment is a tool for fair comparisons of products and for identifying so-called hotspots. Hotspots are stages in the life cycle that cause the largest impact. To identify these hotspots, it's important that we
I'll use the aspect climate change as an example. You work with ruminants and you know ruminants produce methane, which contributes to the climate change. Methane is only one of several greenhouse gases. If the boundary of the system we study is the farm gate, the assessment of the total climate impact includes greenhouse gas emissions from the animals themselves, the ruminants, from the feed production, from soil, and from the use of fossil fuel for the tractor and other machinery, and from the use of fertilizers, and also from the handling of manure. Different gases contribute differently to the global warming. To be able to compare climate impact of different production systems, the emission of greenhouse gases are all translated into kilo carbon dioxide equivalents. That is a standard unit. Methane has a much stronger instantaneous warming effect than carbon dioxide, and that is why milk and beef production contribute more to climate change than production of pork and eggs. But carbon dioxide remains much longer in the atmosphere than methane. Assume we open gas bottles and let out 1 kilo of each gas now. Poof! After 12 years, the methane has been broken down in the atmosphere, but the carbon dioxide is still there. Carbon in oil was stored in the underground until exploited by humans, and without humans, the carbon would have remained underground. When we use fossil fuel, a large part of the emitted carbon dioxide remains practically forever in the atmosphere. That's why sustainable agriculture and the whole society must become fossil fuel free as soon as possible. But fossil fuel is still used, and therefore the global methane emission needs to be reduced substantially from the current level. Instead, the global methane emission is still increasing. So, short and simple, when we no longer use fossil fuel, low constant methane emissions from ruminants will be okay because of methane's short biogenic carbon cycle. But we are not there today. Different production systems use more or less fossil fuel. In organic systems where no pesticides are used, weeds are controlled mechanically and more fossil fuel is needed for the tractor. But less toxic substances are spread in the ecosystem as pesticides are not used. That's a classical example of a goal conflict. On the other hand, it is very energy demanding to produce fertilizers, and fertilizers are not used in organic production, which in turn results in a lower yield, another goal conflict. Cattle raised on concentrate can have a high growth rate and emit less methane per kilo beef than cattle on pasture, especially natural pasture where growth rate is rather low. But cattle on natural pasture can contribute a lot to biodiversity. So there you have another goal conflict. Life cycle assessment can reveal hotspots that need to be improved and also reveal goal conflicts, thereby stimulating discussions on what is important to change. Back to the life cycle assessment. I will now present the results of a life cycle assessment of two different milk production systems in France. The boundary here is the farm gate and the functional unit is 1 ton of milk. Concentrate feed included imported soybean meal and palm oil. One system is a rather extensive system with Montbéliard cows in highlands, and one is a very intensive system with Holstein cows fed maize silage and concentrate in the lowland. And in the lowland system, pasture is not used. The highland system has a milk yield around 5,000 kilo per year, and the lowland system has a milk yield around 9,000 kilo milk per year. Before we look at the results, I have to explain the concept of allocation. Dairy farms produce more than milk, right? They also produce meat from culled cows and all the surplus calves. In the studied production systems, the calves are sold at weaning and raised on other farms, often in another country. So we have three products from these dairy farms: the milk, the meat from culled cows, and surplus calves. And therefore, it would not be fair to count all environmental impacts on milk only. Instead, the environmental impacts are distributed over the three products. Around 80% on the milk, 15% on the meat from culled cows, and a few percent on the surplus calves sold at weaning. The environmental impacts of the beef production from these surplus calves raised on specialized beef farms is not studied here. And that is actually true for many studies of milk production. The calves are not included. The climate impact in carbon dioxide equivalents per ton milk was higher in the highland system than the intensive lowland system. There is almost no difference between the systems in acidification. Higher eutrophication in the highland system, lower energy demand and lower ecotoxicity in the highland system, and higher land use per ton milk in the highland system. Biodiversity was not included in this assessment. With a more efficient system, like the intensive system with high-producing Holstein cows, several of the negative impacts will be lower per kilo milk. Therefore, conventional intensive systems often get less negative impact than more extensive systems, such as organic production systems in a life cycle assessment. Because the production level is lower in organic production, lower feed crop yield, lower milk yield, lower growth rate. It can, however, be misleading to present the results only as impact per kilo product from an overall sustainability perspective. With a more effective production, we can intensify agriculture and use more and more inputs and produce more and more products, and thus continue to increase our consumption more and more. Is that sustainable? No. For a sustainable development, we rather need to adapt the consumption to the amount of available arable land on the globe. Arable land is not an endless resource. On the globe, there is 0.2 hectare arable land for each person's food production. Let's see the environmental impact expressed per hectare instead of per ton milk. So here the functional unit is 1 hectare. In this comparison, the most efficient system with the high-producing Holstein cows has a larger negative impact per hectare in all aspects as compared to the highland system. So the highland system is more environmental friendly when we perform the assessment per hectare. But note that we get much less milk per hectare in that system. We would need to adapt to reduce our milk consumption if the highland system should become the main production system. So we have 2 different perspectives giving different results in the sustainability assessment. That gives us something to think of and to discuss. Which perspective do you have? We have compared conventional and organic Swedish pork production and conclude that when assessing systems differing in efficiency, it is wise to assess the impact both per kilo or ton product and per hectare land used in the production system. The most sustainable production system is then the one with a lower negative impact in most aspects, both when calculated per kilo product and per hectare. And in this study, in this life cycle assessment of environmental impacts of pig production, the organic system was more sustainable. But due to lower efficiency, we get much less pork per hectare in the organic system. So, again, we would need to adapt our consumption if the organic system was the main system. In the GenTORE project, we are now performing life cycle assessments of different milk and meat production systems. 2 systems with dairy cows and 1 system with suckler cows. And the study includes environmental, social, and economic aspects of sustainability. Now it's time to end this lecture, and let's have a look at the learning outcomes before we close. I hope this lecture has given you a broader view on animal production's environmental impact and new knowledge about life cycle assessment. Thank you for listening, and you are welcome to listen also to my second lecture, where I will talk more about social sustainability. Thank you.